Hello ladies and gentlemen, and welcome to TheClickedCode. I will be your host. If you are not a subscribed member of my channel, hit that subscribe button so you are notified when I post new content. And if you like the video, remember to leave a like, as it helps motivate me to make more videos. So what do we need for this video? Well, you will need a hackerrank account, and what I'll be doing is going over the first 100 hackerrank easier problems, and then I'm going to go into the medium to hard level problems. The reason is because I want to be able to go over techniques that we can apply to simpler problems that we can use for the medium to hard level problems, right? Like recursion, sliding windows, the two-pointer technique, and so forth. So our first problem is the simple array sum. So we're given an array of integers and we're asked to find the sum of its elements. So for example, if you have an array with the elements 1, 2, and 3, we get 6 as the summation of the elements, right? It says that we need to complete the simple array sum function in the editor below. It must return the sum of the array elements as an integer, right? And then our constraints are that the size and the value, right, in the index I could be between 0 and 1000. So for example, if we're given an array with 6 elements like so, we need to return the sum of all the elements. So it's a very simple problem, but what we want to do is apply certain techniques to solve this problem. Okay, so with all the videos that I will be creating, we're going to use a PowerPoint where I make some type of lesson, and my goal here is to make this lessons, right, not code dependent. So it does not matter if you're a C programmer or a C# programmer or a Java programmer. As long as you follow the steps in your language, you should arrive at the same solutions. Okay, you just need to be able to use the language features, right, in your programming language to complete the solution. All right, so I'm going to go ahead here and I am going to start the slide, and I'm going to start this. Okay, and let that load. So the problem is called simple array sum. If we're given an array with the elements 1, 2, 3, what we're going to do is keep a sum variable, and we're going to initialize it to 0, and then this here is going to just keep track of the running sum as we go through each element. Alright, so for this we're just going to create a single for loop that accesses each element one at a time until we get to the end. We add this to a sum variable to keep track of the running sum, and then once we're done, we're going to return it. So it goes something like this. So the first thing we do is we go over the first element is 1. We have our sum. Our sum has the value 0 in it, and then we add 1 to it, and that's going to give us 1. And then we get to 2, and our sum has 1 plus 2, and that's going to equal to 3. And then we are at the last element 3. Our sum has the previous value of 3 plus 3, and that's going to give us 6, and we are done, right? So what I'm going to do here is I'm going to exit, and we're going to head into hackerrank, and then we're going to go ahead and implement this code. So I'm going to use C# for this one, but like I said, some of my upcoming videos I will use C++, I will use Java, or any other language that I think that is suitable for the problem. Okay, so what we're going to do is we're going to say for each, and we're going to say int, and I'll say n, right, in R. So we're just going to go over each integer in R, right? And then what we need to do is we need to keep track of our running sum. So we're going to keep a sum variable. I'm just going to call this s, and this is going to equal to 0. Okay, so the reason why I'm just giving this variables like single letter names is because I want to avoid typing. I'm not the fastest typer in the world. Okay, so we're going to say that s is going to plus equal the current number, and then all we need to do is return, right, we're going to return s which is just going to hold the sum. All right. So this is pretty much it. What we're doing is we're iterating over each value in our array. So if our array had these values, we go one value at a time. So we go 1, then 2, then 3, then 4, then 10, right, then 11, and then we keep a running sum of the previous values, right? And then when we get to the end, we should have the sum of all the values, which is going to be equal to 31. So now that we have this, let's go ahead and run this code. And you can see that the code is correct. And we can submit. So that works just fine. So let's go over our next technique, which is going to be the two-pointer technique. And I'm going to go ahead and start this at the current slide. Alright, so the two-pointer technique, this is how it's going to work. What we're going to do is we're going to create two pointers. We're going to have a right pointer and a left pointer. These are going to point to the first and the last values within our array. And then what we want to do is we want to make sure that these pointers converge to the center, right, while we access each element. This is still going to take O of n, but it's going to be O of n divided by 2, all right, because the array, the for loop is only going to run n divided by 2 times rather than going one at a time, because we're pointing at two values at each iteration. Okay, so what we're going to do is we're pointing to the first element, and remember that with arrays are based on indexes or subscripts. So our first element is going to be at 0, and our last element is going to be at the size of the array, which is 5 minus 1, right? So which is going to be 4. So let's go into the next slide. So what we're going to do is we're going to have our sum variable again. It's going to be set to 0, and we're just going to keep track of the running sum. So we start with our first value, and this is going to be the right pointer, and then we go left value, left pointer, and we check is the right pointer less than the left pointer. If it is, then we have our sum, that was 0, plus the value at index 0, which is 1, plus the value at index 4, which is 5, and that's going to give us 6. Now we move to 2, and now we are at the index 1, and then the left pointer is going to be at index 3, because we're going to decrement the left since we're trying to converge to the center. And then we're going to check to see if the right pointer is less than the left pointer, right? It is. So we're going to have our sum variable with the previous value of 6 plus the value at index 1, which is 2, plus the value at index 3, which is 4, and that's going to give us 12. Now we're going to increment the right pointer, so it's going to be pointing to 3, and the right pointer, the left pointer, is going to be pointing to 3. All right, so we check, is 2 less than 2? Well, 2 is not less than 2, so we're not going to add this number, so our sum is just going to remain 12. Now these two pointer techniques could be used for reversing things like string, or checking to see, right, if a string is a palindrome or not. Okay, so or reversing an array. So it's useful for different things. So what we're gonna do is I'm gonna make this clear that if you're adding in the elements in an array, and the array has odd number of elements, right, you need to account for the middle element. And how do you do that? Well, let's say we have the array A with 5 elements like we did, and what we need to do is we grab the size of the array. So if our array was A, we get A.length, and that's going to equal 5. And to get the middle element, right, to get the index for the middle element, we just take the number of elements divided by 2, and that gives us 2. So now if you go over here, you can see that 3 is actually at index 2, because we have 0, 1, and then 2. So now we have our sum. It had 12 in there, plus the value at index 2 is going to equal to 15, and we are done, right? So let's go back into hackerrank, and let's go ahead and solve this. So what I'm going to do is I'm going to keep S, and this time what I'm going to do is I'm going to create the right pointer. I'm just going to set it to R. It's going to be 0, and the left pointer is going to equal to R dot length, right, minus 1. Okay, so remember that the length is always going to be 1 above, right, the last index in the array. So we're gonna create a while loop. So we're gonna say while r is less than L, right? Then we need to sum. So we're going to say that S is going to plus equal, and we could say R, and we're going to pass in R, and we're going to post increment, okay? Plus R, and then we're going to do L, and then we're going to post decrement. So what this does is that it's going to go ahead and use the value in R, and then it's going to go ahead and increment after this operation is done. All right. So then it's like we're using the right values to access. So we don't actually have to put the R++ right at the bottom. You can just do it right within the brackets. Okay. So once we're done, we can return S, right? So there's a flaw with this problem because it did not say that all of the arrays are going to be of even length. So if you go ahead and run this, it should actually work, right? If you submit this, it actually works for all the cases, but it does not take care of the middle element. So let's actually take care of the middle element. So for this, we need to check. I'm going to say that if R, right, dot length, right, mod 2 is equal to 1, right? So we're saying that if it's equal to 1, right, meaning that it's actually odd, then what we need to do is we're going to say that S is going to plus equal, right, R, and then we're going to use R dot length, right, divided by 2. Okay, so now we're just grabbing that middle element, and then we are adding that to S. All right, so we're adding that to the final sum, and if we run this code, it just still pass. All right, you can try this on your own. You can create an array with 5 elements and then run this, and you can see that it actually works. Okay, so let's go ahead with our last technique. And the last technique is recursion. Recursion is one of those things that a lot of people don't want to see, they don't want to touch. When they see it, they all get scared, right? But you need recursion if you're going to be dealing with data structures like linked lists and trees and some other ones, right? Some other problems that you might want to optimize, right? Like using DB for dynamic programming and stuff like that. We're gonna get into those when we get into problems that use more advanced techniques. So in this case, we need to recurse over each element, and then we need to return the sum. And for you to actually understand how recursion works, you need to be able to understand how functions are placed on a call stack. And if you don't know that, what I'm going to do is I'm going to look for a good video on YouTube, and I'm going to have it in the description section of this video. So before you actually go through this, you can watch that, and then you'll be able to understand exactly what's going on in the recursive call. So let's go ahead and go over the recursion, and I'm going to start this at the current slide. Okay, so this is recursion. So if we are looking at recursion, we can look at finding the factorial of 5. Okay, so how does this actually work? So the way that function calls work, I'll give you a simple plain overview of that. Is when a function calls another function, right, and that function wants to do something, it's placed on a call stack. Okay, and the reason is because when that function is done doing something, it needs to return to the function that called it, because it needs to know, that function that calls it needs to know if the function inside of it, right, is done doing the work that it's supposed to do and then it returns back to the function that calls it, so that function can move on to the next piece of code that needs to be executed, right? So in this case, what we need is a way, right, to stop the recursive call. And a way for us to stop a recursive call is called a base case. And that's pretty much how that works. So here's the overview. So in our case, what I'm going to do here is I just give you guys the function, because it's hard to explain it without really showing you guys some piece of pseudocode on how it actually works. So our add function is going to take in our element, and it's going to take in the size, right, of the array. And we're going to check to see if n is equal to 0. If it is, we return 0. And if it's not, we're going to do a recursive call on the elements, and we're going to decrement, right? So we're going to keep adding one element at a time, and then returning the sum back, okay? Just like the factorial was doing. So it looks something like this. So we have our 5 elements, and what we're going to do is we are going to have element on the size. So now it's size 5 because of 5 elements in here. That's going to call it on 4. 4 is going to call it on 3. 3 is going to call it on 2. And 2 is going to call it on 1, and 1 is going to call it on 0. So when 1 calls it on 0, we're going to be at this case here. So we're going to return 0, right? So now we're at 0, and 0 is going to go back into the function that called it. So at 1 is going to be 0, which is the one we had here, plus the element at n minus 1. So in this case, n is 1, right? So n minus 1 is 0, which is the element at the 0 spot. And you can see the element at the 0 spot is going to be 1. So now what we do is we take 0 plus 1, right? And that's going to return 1. So now we go back into the function that called this function, which is going to be 2. So now we say, hey, we had 1 for our previous computation plus the element at n minus 1. So 2 minus 1 is going to be 1. And the element at 1, right, is 2. So 2 plus 1 here is 3, right? So now we go back. So we're going to go back into the function that called this function with the value 3. And now we're going to say, okay, hey, n is 3. So 3 minus 1 is 2, right? So now we have the index 2. And the value at 2 is 3. So 3 plus 3 gives us 6, right? And then we're going to return 6. And then n minus 1 here is 3, right? So the value at 3 is 4. So 4 plus 6 is going to be 10, right? And then we go back into the function that initially called everything, right? And we're going to get back with it at 10. So 10 plus the element at n minus 1, which is 5 minus 1, right, is going to be 4. And the last value at 4, the index 4 is 5. So 5 plus 10 is going to give us the value 15. And we're back up the chain, all right? So how this works is when a function is done doing whatever it's done doing, right, if you called a bunch of functions, and the way that we need to figure out if the function is completely done is when the call stack is empty. So let's go ahead and implement this problem. So what I'm going to do here is I'm going to erase all of this, and what we need to do is write our custom function. So I'm going to do static int add. All right, this is going to take an array. I'm just going to call it E for element, and n for the size. All right, so we're going to say that if n is equal to 0, then we're going to go ahead and return 0, or we're going to return add, right? And we're going to take in the element, and we're going to take in the size minus 1 plus our element array and the size minus 1. Okay, and now in our sum function, what we're going to do is just return add, right? And we're going to pass in our array and our array dot length. Okay, and that's pretty much it. So this is how a recursive technique would work. So let's go ahead here and run this. So that's correct, and let's submit. Alright guys, this will be it for this video. If you enjoyed the video, please do leave a thumb and a like, and if you have any questions, leave a comment so I will be able to respond to you. And as always, have a good day, and I will see you on the next tutorial. Bye bye.